This video is going to kind of take what we have been talking about and go into a little bit more depth with how we can build vectors and how we can take them apart a little bit and describe them in various different ways. So let's pretend that what they told us in a question was the direction that they wanted us to go and how far they wanted us to go, and from that we had to build the vector. So in this question here, we want to go at an angle of 120 degrees. That's like how we would measure on a unit circle, and go a distance of 8. The notes basically say to do that, to find the vector v that would fit that, simply take cosine of the angle times the magnitude, and then sine of the angle times the magnitude, and that will get you what we're looking for. I want to try to explain where that's coming from. So this is basically, it's pretty close to this vector here in red has a magnitude of 8, it has a length of 8, and the direction is 120 degrees. What I mean by the direction is this angle right here. That's 120 degrees. The reason that our formula will work for this is because if this was my unit circle, I can basically, from that unit circle, I could maybe build the unit vector that fit there. And that's simply going to be, if it's on the unit circle, cosine of the angle would get me the x value here, sine of the angle would get me the y value there. That's just kind of going back to beginning of the year stuff and connecting it to the unit circle. So if I were to do that with 120 degrees, I would get the coordinates negative 0.5 and about 0.87 for y. So I know that will tell me the direction, and now this has a length of 1. I want it to have a length of 8, and so all I would have to do is take these two numbers and multiply by that new length that I want, and it should scale appropriately. And you can see negative 4 comma 6.92, it looks like this red vector has gone 4 to the left, and it's almost to 7, so it does seem to work there if I just multiply this by 8 and multiply that by 8. So that's a quick visual demonstration of what's going on here. The formula way, or basically what I would want you to write down for something like this, is simply that vector v should equal, and we're just going to follow this formula there. So I put the vector symbolism, it's going to be 8 times cosine of 120, comma, and then 8 times sine of 120. Close the vector symbolism there. Now we certainly can go through and do some of this in our head. Cosine of 120, if we go back to the unit circle, is going to get us negative 1/2. Negative 1/2 times 8 would get us that negative 4 that we had talked about. I don't think it's bad if you use your calculator for some of this, but just keep in mind there are certainly ways that I could ask these questions that you could get an answer without a calculator. So I think the next one is a good example of that. 8 times sine of 120. Sine of 120, well, if we went through and we kind of thought through what sine of 120 is, it's related, you could say, to sine of 60. Sine of 60 is going to be root 3 over 2. And in this particular quadrant, it's still going to stay positive. So we'd have root 3 over 2 times 8. Okay, what's root 3 over 2 times an 8? What's 8 times root 3 divided by 2? That gets you 4 root 3. Okay, and then that we could simplify. This is where we'd have to for sure use our calculator and get negative 4 comma and the 6 point, it's actually closer to 9.3 than what I had on Sketchpad earlier. So that's one way we could do this, where I gave you the magnitude and the direction that we wanted our vector to be in the end, and I would ask you to come up with this component form in the end of what the vector would look like. Now our next example here is going to go in the opposite direction. Okay, it's going to say find the magnitude and direction angle if u is this, if the vector is already this. So let's go ahead and again go back to Sketchpad and think about what that might look like. I'm going to hide a few things here. Oops, I wanted to leave that up. Hide the circle. Okay, so I'm going to take this vector, I'm going to make it fit our new situation. So let's make it fit negative 2 comma 3. So it goes something like that. Okay, pretty close to negative 2 comma 3. So you can see the magnitude is about 3.62. The direction angle is about 123.6 degrees. That's what we should expect to get here. And let's just kind of walk through what I could do mathematically to figure that out. Well, it's going to be easiest to find the magnitude right away because I have a very easy magnitude formula. Remember, that was just using the Pythagorean theorem basically. It said take the square root of the x value squared plus the y value squared. Okay, so this would get us the square root of 4 plus 9, which is the square root of 13. Okay, go ahead and try to type that into your calculator if you want to. Square root of 13 gets me 3.6, we'll say 1. Okay, 3.61, which, go back to Sketchpad, and that was pretty similar to the magnitude that Sketchpad had for us. So it does seem to work there. Now, how do we figure out the direction angle? There's lots of different ways to kind of think through this. And so you do need to come up with a method that you think will work. I think a lot of times, to be honest with you, it probably just makes sense to think of a picture of the situation. So we have our vector. It was at negative 2 comma 3. So that's somewhere up here, right? Okay, that was the vector there. Well, I can kind of easily draw in these two sides here. I know that this was negative 2. I knew that this was 3. And I could pretty easily think of this being related to just a right triangle. Okay, I could say that this is even 3.61. So if we just think about this as a right triangle for a little bit, and I'm interested in finding the direction angle. Now that's the angle that goes to here. I have lots of choices. I probably am going to start by finding the angle that's in here and then just applying that angle to this general picture. So again, you have lots of different options of how you want to solve this, but I would generally say, even if you go and look in your book and the book says something different, I would almost suggest you just go back to right triangle trig. I think that's going to be the easiest method. So I look at this, and just because the 2 and the 3 are kind of nice numbers, I might just go ahead and say let's use tangent. Okay, tangent of theta. And when I use theta right now, I'm kind of talking about this angle right in here. Okay, tangent of theta is going to be opposite over adjacent. So that's going to be a 3 over 2. I would, in this case, probably ignore the negative symbol right there. I know that in previous units we've used negative there, but in this case I might just go back to the very beginning of the year, just typical right triangle trig where everything was positive. So I might do that. So we're looking at where does tangent of theta equal 1.5. I can now use inverse tangent. So make sure if you're using your calculator and you're trying this on your own that your calculator is in degree mode. I'm going to go inverse tangent of 1.5. And I get 56.31 degrees. So that's going to get me theta would equal 56.31 degrees. Now that is this theta. Remember that I wanted this angle. So in this case, the angle that I want plus the 56 that I found is really that should equal 180 in this case. You always got to go back and say, well, what's the picture kind of referencing here? So the angle that I actually want is going to be 180 minus 56.31. Go ahead and type that in on my calculator, 180 minus 56.31, and I get 123.69 degrees. Okay, so that should be the angle that I'm looking for, the direction angle. Quick, go back to Sketchpad, and you can see right here 123.6, pretty close, and my vector here was just a little bit off anyway, so I think our algebra work is probably closer. So the things that you want to take away here are the magnitude was that 3.61. Okay, the angle measure here was 123.69. I chose to use tangent, but I could have used sine or cosine and just used the variety of different side lengths right there. So a little bit more going on here. It can get pretty complicated. Our book probably describes things a little different at I think I got cut off there right at the end. So I'm not sure what you're going to hear right at the end, but just realize that you could have used sine, cosine, or tangent to help you find this angle. Your book probably describes that method much differently, so to me this is the easier way, but you certainly can look at your book as well. Okay, I'm going to stop there.